Results, Part 3, which is a tutorial. This tutorial will be primarily focused on helping people who have access to TechPlot 360 2011 R1 and who are working with unsteady analysis. So let's go ahead and get started. So as I said, this is going to be much more of a tutorial. I'll be joined by Steve Robinson. Good morning, Steve.
Good morning, Darrell. Hi, everyone.
Steve will be walking through the tutorial, and so I'll be turning it over to him shortly. Just quickly, let's just review where we've come from, and we've really gone through two series up to this point. We've started with talking about just some of the theoretical constructs around working with unsteady results. We then had a more practical session where we went through some strategies that you could use for working with unsteady CFD results, specifically looking at a couple of examples where we were modeling some turbulence. In this final session, what we're going to focus on is a tutorial. The intent is twofold. One, the tutorials will be recorded and available via our website by the end of the week, and you'll be able to go through and watch the recorded video of each tutorial in addition to the overall webinar. We'll also make available the cases that we used with the tutorial so that users will be able to follow along with the recording and actually apply some of the things that we're going to talk about here this morning. So this will be a nice opportunity for those people who it's hard to follow along sometimes, as you may not be familiar with some of the functionality. They'll have an opportunity to go reproduce some of these examples. So with that, let's just quickly review. In the first session, we talked about some of the qualitative and quantitative implications of moving from a steady state to an unsteady result set. And Scott, Emily, and I reviewed some of the things, including the differences between stream traces and streak lines. We talked about some of the quantitative analysis, including Fourier transforms, as well as how best to present the information if you're looking at vortex shedding or other turbulent events. In the second session, we went through two cases. We looked at a 2D wind turbine, where we walked through how one can quantify those results, as well as a simple vortex shedding test case for turbulence modeling. And we tried to walk through how one can actually automate some of those analyses, as well as creating templates for reporting. And there was plenty of time for Q&A. Now, just a quick note on Q&A. If you look on your GoToWebinar sidebar, there is a section where you can ask questions. Those questions can be typed in, so if you have a question, you can type in as we go along. So as Steve is going through the tutorial, if you have a question, feel free to type it into the question dialog, and he and or I or one of the people here at TechPlot will either answer you right away, or we'll leave time at the end to answer questions as we go along. In addition, for those who have microphone access, if you raise your hand during the Q&A, there's a possibility we'll be able to unmute it. We did have a technical issue with that last time we tried it, and so it's hard to know whether or not that's going to work this time, but we will certainly give that a go as well. So with that, let's talk about what we'll do with the third session here. So we're going to quickly, as I said, we just reviewed, in effect, what we did in the first two sessions. Then we'll start with a tutorial. Case 1 will be more of a 2D unsteady case, followed by a tutorial on a 3D unsteady case. And we will leave plenty of time for Q&A. We still have some people coming on. Hopefully everyone can catch this. And as I said, this will be recorded, so if you missed any of the beginning portion, you can go back and view the recording. So just a quick note, again, probably one of the key things that we're hearing over and over with those people both in our customer base and the industry in general is that one of the key things people are struggling with is how best to quantify or analyze unsteady results. So that includes things like integrations of mass flow rates, forces and moments, mass-weighted averages, scalars. So we talked about the frequency domain. And so one of the key things we'll want to make sure that we focus on here today would be not only qualitative analysis, in essence making, let's say, an animation of a turbulent model. What we'll want to talk about is how one can quantify those results. And with that, we're going to get started right away by looking at our first tutorial, which is a 2D analysis. And with this, I'm going to turn it over now to Steve Robinson. Steve, I'm going to turn it over to you.
Okay, so you should see a TechPlot 360 window here. If you don't, post in the question or the question field or raise your hand and see what's going on there. Okay, so in the first tutorial, and let me pull up my version of the PowerPoint here. We're going to take a look at probing over time, both just to see some values and to create a whole time series. We're going to look at just a time animation showing this unsteady case over time and how you can add some dynamic text annotations. We'll take a look at a visualization in multiple frames like you see here in the image of the PowerPoint. And we'll also take a quick look at a particle path calculation or maybe even a streak line calculation. Okay, so what I have here is a set of TechPlot data files, each with one time step. So we have 60 time steps here. This could have been all in one file, multiple time steps in one TechPlot file. Here, it happens to be in multiple files, one time step per zone. So all you would need to do is single click at the top of the list, hold down the Shift key, and click at the bottom of the list, and you could select everything and just go ahead and open it from here. And I just used the TechPlot data loader to load this up. So it was just under File, Load Data File, TechPlot data loader. So we can start just by turn on the contour and get down to closer to this stationary object here. So you can see we have a vortex shedding over a stationary cylinder. I'm just going to go in here and turn on the contour. So I just went to the contour and multi-coloring details. And just a quick note, while this tutorial has been designed for 360, it should work for focus in many cases. I'll try and point out the things that don't work in focus. Primarily, it's the Analyze menu features that won't work in focus. So I'll hit Control-Z to reset my view. So from here, we could just go ahead and animate. In focus, you could animate through the Animate menu. You can see we have our pressure contour animate over time, get to see the pressure variation, the undulation here over time, and it's nice. But certainly just the first step in showing a detailed analysis of your results. So just one quick thing we could do just to get kind of a so if we see a point of interest that we want to take a closer look at, we could certainly click on the Tool to Probe Data tool and just click on a single point and get an idea of a certain value, such as pressure at that point. So, and when we step through the animation using the plus or minus keys here, we would see this value change. That's actually an update in 360 2011. And in addition to that, we might decide, okay, well, I know there's something going on here. I'd really like to see a line plot of that over time. So what we could do is go to Tools, Time Series Plot, probe to create a time series plot. And what we could do is probe at a location, and we would create an XY line plot of the contour property, in this case pressure, at that location. So we could just do it downstream of the object. You can see we're now seeing this undulation in the line plot as we're seeing just by looking at the animation. So now we can play forward, and we have a marker that shows at what specific solution time we're at, so we can track the 2D image against the line plot image. And this marker is actually something new in 360 in Focus 2011. Okay, so another thing we could do is, let's say we're looking at pressure. We definitely want to see pressure, but we also want to see another view of this plot. Say we want to look at the temperature as well. So what we could do, all I did is I clicked on the selector tool and selected this frame so that I could copy it. And then I'm just going to, so I can go up here and just actually do edit copy and then edit paste, or Control-C, Control-V, whatever you want to do. And we could actually create a temperature contour plot. And I'm going to tile these out. We could just move them around. I could just resize this and move around. See, there's the previous frame. We have all three of our frames here. We can move around, overlap them however we want. Or if we just want them tiled so we can see them all, we could go into scripting and select quick macros and select tile frames. It's one of these macros that comes packaged with the product. And we'll just have it tiled 2 across the page. So then they'll tile nicely here. So that makes it easier to see, although now we kind of have some decoupling in what we're looking at. We're looking at something different here versus here. So what we can do is we can link these frames. First, let's take this frame out of the group. Let's put this frame into group 2. Since we don't want the spatial linking to match, since obviously this is in time space, these are in X and Y space. So I'll go into frame linking. And so this frame and this frame is in group 1, as you can see here, but when I click on this frame, it shows it's in group 2. So what we'll do here is link the X and Y axis range of these 2 frames, so that when we apply that setting, we're now looking at the same view in both of these frames. You can see they update here. And now when you play them, they're also animating. So all along they've been animating at the same time. Now they're showing the same view. We're not using this one. I'm just going to go ahead and select this frame and delete it, just to give us a little more room. And actually, so one way you can tile frames was in this quick macro, but there's also a way you can just go into the frame menu and select tile frames, and then just click whichever configuration you want to tile it as. You can do a vertical orientation, kind of a split screen look here. Maybe it'd be better to do it this way. And then we'll just recenter here. So I hit Control F just as a shortcut to fit the screen, although it'd probably be better if I just click the magnifying glass and get back into a zoomed in view. So there's a question that came in about issues when linking frames. Not exactly sure what he had done, but sometimes the frames that got deleted and only one had remained. I'm not sure offhand what might be causing that. So toward the end, we can talk about that a little bit more. Might be able to reach out to you one-on-one as well and see if there's something we can do about that. But I'd recommend, if you haven't tried the new version already, to go ahead and give that a shot. in case it was an issue that had been resolved. Okay, so while these two frames are still linked, you can still, they're linked in some ways but not others. So we could, for example, add vectors in this frame, and they're not going to be added in the other frame. And so another thing we can do is add stream traces to this frame, and that will be a precursor to particle path calculation as well. So all we need to do here is click the stream trace checkbox. It will show us what variables are going to be chosen for the components of velocity. So we can go ahead and click OK if we're happy with that, which we are in this case. And then what we can do is essentially seed a rake of stream traces where we'll trace out a line with this add a single or rake of stream traces, and that will be the part where those stream traces start, and then they'll integrate forward and backward in time. So I'll just go ahead and click on that, and I'll just draw a vertical rake since we know that we have flow moving from the left side to the right side of the plot here. So once I let the mouse button go, then it will produce a stream trace. It's 10 evenly spaced stream traces along this line. And if you want to tweak those settings, you can always click on the option button to the right of stream traces, and you could adjust the rake, or even explicitly define start and end positions. Okay, there's another question that came up. With respect to adding a vector to your plot, how do you handle meshes with a large number of, say, 60,000 nodes in TechPlot? Okay, so that can definitely be an issue because you turn on the vectors and you have blackness because the vectors are so closely spaced together. The one thing you can do is click on zone style, select points, and you can enter an index skip. If it's an ordered zone, it will give you I, J, or K dimensions to skip. Otherwise, it'll just give you an I skip. So we could just show every other vector in this case, for example, and click OK, and it will thin out the field for you. So you can find the sweet spot where you have good coverage of the vectors, but you don't have them obscuring each other and not letting you see the results. And another question came up, how do you change the frequency of displaying arrows and their sizes? So the frequency goes back to thinning out the vectors. In terms of the arrows and their sizes, that can be defined in the plot menu under vector. So you can define the vector length, and then if you go to vector arrowheads, you can have it defined as the fraction of the length. So it would relate back to this relationship here, this relative relationship. Or you can define the arrowhead as an explicit size. This percentage unit is a percentage of frame size, so it's relative to the frame itself. And another question came up regarding stream traces. Is it possible to do it backwards with stream traces, meaning giving a point? And yeah, Dorella just pointed or posted an answer there, and yeah, it is possible just to show that dialogue. You can integrate, you can choose, by default you integrate in both directions, but you can choose to do a backward only integration. So good questions. Keep them coming. So another thing I wanted to show is it's definitely of value to be able to show some dynamic text properties as you're animating. A lot of times people want to show the solution time, but that's not all you could show. So you can do that by clicking on the Add Text icon, and then click at the location you want to add the text. And you can add static text, t equals, and then seconds for your unit. But you can also add what's called dynamic text. And for solution time, it is essentially placed ampersand followed by parentheses, and then within those parentheses, solution time. And if you're wondering how to find these dynamic text strings, I'd recommend clicking on the Help button within the Text Details dialog. And the Help buttons in each dialog brings up context-specific information based on the dialog you're in. So it's a very handy way to get at the manual without flipping through a manual. So we'll just go ahead and click on Help here. Scroll down. So there's a dynamic text link here. And here's where you would find the whole listing. So solution time, for example, is the one we used in this case. So you can find the dynamic text string you need and then apply it to the text box. You can see when I animate now, it's actually showing the time as you go. We can always single click and move this around, or double click on it again to edit the text window. Okay, so we've talked about streamlines here. And oh, it looks like there's another question on streamlines. So is it possible to animate the streamlines from upstream to downstream? You can turn on markers. And then you can go in. So just so I'm not clicking through like crazy here, I clicked on the Stream Trace Options button here, and then clicked on Timing, and then selected Show Markers, and that brought these markers up. And then you can go to the Animate menu, select Stream Traces, and you can animate those markers. So it's showing an upstream to downstream animation just along the streamlines at that instant in time. And just to reiterate, the streamlines, or the stream traces, really, it's an interchangeable term, are showing the flow at that instant in time. So as we animate over time, the streamlines actually change. If what we really want is where is that particle going to go based on essentially how the flow is changing over time, then we would want a particle path calculation. And this is something that's available in 360, not available in Focus. It's within the Analyze menu. And essentially, it uses the stream traces as the reference point, the reference starting point to calculate the particle paths. So just to keep this from getting too cluttered, I'm going to turn the markers off and go ahead and get set up for the particle path calculation. So to start, we'll go to the Analyze menu, select Field Variables, and change the convective variables to velocity. We're going to need that for the integration of the particle paths, and it's already chosen the U and V variables for the velocity components. I'm happy with that. I'll click OK. And now I'll go into the animation the Analyze menu, and choose Calculate Particle Paths and Streak Lines. We'll choose Particle Paths and click Calculate. And we'll go into Zone Style, select Mesh, and we'll turn the mesh off for the solution zone, but we'll keep it on for all the particle path zones. So when I turn on the mesh, it's going to show the particle path. And I'll change the mesh color so we can see it a little bit better. And maybe I'll up the line thickness a little bit. So you can kind of see the relationship here. Everything, the particle path and the streamlines are roughly the same here, but as you go downstream and hit the downstream undulation behind the object, you see that the particle paths start to deviate from the streamline. So it's basically what we would expect. Okay, it looks like we have a few questions to catch up on here. Let's see. Okay, so clarification on the previous question on animating streamlines upstream to downstream. The question was actually the development of stream traces from upstream to downstream. This is useful for visualizing the flow development without being clouded by many streamlines for the entire flow field. Gary, if you have, let's see, that may be a good one. If you have a microphone handy, that might be a good one to talk about toward the end. Otherwise, we can definitely get back to it. I just think some back and forth on understanding the question might be good for trying to answer it best. Okay, so another question that came up is, can you animate the particle paths? The particle path is essentially stationary, but you can animate the streak lines, which I'll show here in a minute. So I'm going to go ahead just to keep the view somewhat clear. I clicked on zone style here, and I'm going to deactivate these particle path zones. And then go back to the calculate particle paths and streak lines. And so instead of particle paths, I'm going to choose the streak line calculation. And I'm going to go ahead and calculate that. Okay, so in this case, I'm going to turn off the mesh and then turn off the scatter for the original solution zone, so we're not seeing the mesh of the solution. Whoops. Not deactivate the zone, but just don't show the scatter. And then, so we're showing the scatter scatter for the streak line. So I'll go ahead and turn on scatter. And so now we're essentially just showing the actual particles as they're being integrated through the flow. And so if we go back to calculate particle paths and streak lines, I probably could have just kept that dialog up. Now we can click animate. And so it's showing an animation of the particles, animation of the flow, and it's still showing the stream traces on here. So you can see you have a lot of combinations at play here. And it's really just a matter of how best to effectively show the results based on preference and what's going to be easy for the audience to see. Okay, so another question came up. Can you calculate particle paths backwards? Good question. I don't believe so. I believe it's always forward on the particle paths. What we might want to do is have some quick follow-up information go out. I don't know how that would work exactly, but if I can get some confirmation on that, I can send that out. Okay. Any other questions on this example? I want to definitely leave enough time to spend some time with the 3D analysis, but I want to make sure we're okay on this one so far. There will obviously be some overlap in the 2D versus 3D analysis, so there's always going to be a chance to come back to concepts that are of interest. Okay, I'll go ahead and just minimize that so we'll have access to it later if we need it. So the second tutorial involves a 3D analysis. It's a lot of the same beast as the 2D analysis, just a third dimension, a few other options at play. So we'll start with slicing through the 3D solution, which is obviously very a common thing to do for a 3D volume analysis. And then we'll go through an integration over time strands. We'll also talk about what time strands mean in the context of TechPlot and what you can do to leverage that to your advantage. We'll look at a keyframe animation, essentially a change in the view over time and how that can help make a more dynamic presentation. And then we'll do a video export and talk a little bit about that. Okay, so this example is a Plot3D data set. So I'll go to the File menu and Load Data Files, and I'll select the Plot3D loader. Okay, we had a question just come in. Can you have a rotating 3D geometry if the 3D analysis is done using a rotating reference frame? Okay. Let's see. Let me make a couple notes here. I think this one and the previous one that had come up from Gary would be good ones to talk about later, since there might need to be a little back and forth on that. Okay, but we'll definitely leave some time at the end. Okay, so I'm going to start by adding the grid file. It's in the tutorial 2 folder, which we'll try and keep it in the same format when we put it up on the website. So we'll add that XYZ file for the grid, and then we'll add our solution files here. Again, you just need to single click up at the top of the list, hold the shift key down, click at the bottom of the list, and we can add it and open the file. So we have our solution set and our grid set. And we'll just click OK to open it. And I will zoom in here. So the shortcut to zooming in, if you don't know, is just holding down the middle mouse button or the track wheel button and then moving the mouse down to zoom in. You can hold the right mouse button to pan. And can also rotate up here. Rollerball rotation is probably most popular because they'll move along any axis, whereas these are constrained by axis. So to start, we could just turn on a slice by clicking the slice checkbox here. And kind of a nifty shortcut, if you don't know, is you can actually click the Y key once you've selected this add a slice box here, or icon here. You can click Y or X or Z to change the the slice orientation, or you could always click on the option button and then click on go to the slice location X, Y, or Z planes here and change the orientation that way. Just a few different options to change the orientation. So I'm going to flip this around a little bit just so I get a better view. We can stay zoomed in. So again, it's just a matter of playing the animation. So one of the questions that comes up a lot with users is if the data file isn't set up to be a time animation, what do you do to make it ready to be a time animation? If you just have a selection of data files, maybe they're not even in a TechPlot format, or maybe there's something that was more homegrown from your own modeling, how do you make it a time animation in the eyes of a TechPlot? So that can be done, it can actually be done in the data file itself, but if it's not already in the data file, you can go to the data menu and select Edit Time Strands. And it will show you a full listing of all of the zones loaded in TechPlot at that time. And so you could go in here and assign the solution time. Quickest way would be a constant delta, where you would have an initial value and how the time changes over time. And if it's constant, obviously this is going to get you what you want based on setting the initial and delta time. And by clicking apply, it would apply it across the zones, and you could animate over time. The other parameter here is called time strand. And what this does is it lets you group several group zones over time. So in this case, I'll move this dialog out of the way and go to zone style. So while it all animated contiguously, what's happening behind the scenes is there's actually different pieces of this mesh that are thrown together, essentially. So if we just click on one zone and choose Show Selected Only, you could see here's a segment of the volume around this cylinder. You can see we have multiple sets here. If I just click and drag down the list and click on Activate, I can show everything again. So what we want is to group those different zones so they animate together over time. And you do that with the time strand. So you would have all of the zones associated with this segment, for example, have the same strand ID. So you can see as we arrow through this list, the updated parameters for the selected zone is shown. So you can see there's 14 strand IDs. These are the different segments of the zones for the first time step. You can see the solution time isn't changing here. And so this is repeated across the different zones. So if you have multiple blocks of the same time series, then you can still animate them together. And you can also integrate them together, which we'll also cover. Okay, so we have a new question that came in. If you have a large number of time steps, say over 1,000, and they are large files, is it possible to do any of this in a batch mode by loading one file at a time to save memory? Yes, yes, this is definitely possible. And it can be done. Essentially, it would be a batch mode type situation where you could record actions within the scripting menu of the basic strategy for doing automation TechPlot is record what you can, and you may need to generalize some steps later. And so what you would do is it would essentially be a loop where it loads subsequent files. Ideally, it would be good if they're named the same, just with a different number at the end of them, for example. And it could capture a given frame and save it to a video. So you could still show it interactively. You could have it show on the screen as it's doing this, or opt to not have it show on the screen while you're doing this. But the end result would be a video that has your full animation over time. You know, it's going to run nice and smooth and quick because it's all pre-rendered. And as long as your computer has enough memory to open that one file, then you would be able to do a batch of that. So yes, that can definitely be done. For a little bit more information on that, it's actually discussed in the manual. So if you just go to the documentation section, and on Linux this would just be in a doc subdirectory within the install itself. But in Windows you can get at it at the start menu. Select the user's manual, and in fact we could have gone straight through here, the help menu, and got to the TechPlot manual that way as well. And the section this is discussed is under Advanced Topics. There's an animation section. Let me zoom in on this a little bit. And movie creation with macros is the section you'd want to look at. And it even has a template here that you could work off of. So you could record the setup of the animation, any of the style settings you want to set, and then paste it right in the loop. And that should get you there. I guess the only other thing would be opening the file. So I guess the other section that would come up would be the batch processing section. So between those two sections, the tools are available and explained on how to do that. Okay, another question. Can you give a few examples of applying value blanking to animations? So value blanking in animations can essentially work the same as in a static zone. So what we could do is go to plot blanking and value blanking. We could just turn on blanking and activate it. I don't know what we want to blank in this case. Just for fun, let me probe. So what we're showing here, by the way, is that we're showing a contour of row. So we could blank just by probing this area of relatively larger values. We could blank when row is greater than or equal to 0.08. And then since it's on a slice, we'll need to go to the slice dialog and under Other, choose Obey Source Blanking. Let's see. Another follow-up question is row equals density. I think might, I'm not exactly sure. Based on the fact that we seem to just have a row instead of a pressure, I believe that's the case. Okay. Let's see. I'm not exactly sure. I might be. Oh. Ended up crashing on me. Okay, since we have it up here, I can show the blanking here, and then we'll go back to that case. So here it's just blanking by X. So as you animate in time, it's still keeping it blanked in that way. Okay, so let me get back in to the 3D case. And if I had saved a layout file, we could have gone right back to where we were. But I did not. Since the layout file would retain style settings along with any calculations, either journaled or explicitly defined in the data file itself, and we would have been in good shape. So layout files are a good idea. And if you don't know, you can save layout files under File, Save Layout As, and it will let you save either a layout that links to the data and keeps the layout file small, or you can save package data layout file, which is going to save everything, the data, the style settings, all in one neat little package. You may have seen the drawing interrupted showed up. That happened because I was clicking around while it was rendering, and it interpreted that as I wanted to stop. So if that ever happens, you can always hit redraw all or just go to the next step, and it will automatically re-render. So we just got one question in on the layout file. Sometimes the layout won't reopen unless there's an accompanying PLT file. Please explain. So that would be one of the linked data files where it's looking for a specific data file or set of data files. And in that case, you need to make sure not only are the files present, but they're in the same path relative to the layout file as they were when it was saved. Otherwise, you'd come up with some errors where it can't open that file. So if you're moving the data around a lot, you may want to opt towards the package data, although that has the disadvantage of being a huge file every single time, where you can have multiple linked layout files that would be small that link to the same data set. So it's really a matter of what you need to do. Okay, since we're running a little bit low on time, I'm going to go through the steps of this tutorial, and then we'll go back to questions. I just want to make sure those that have a tight schedule get the full tutorial, and then we'll go through the questions. We may go a little bit over, but to those that can hang around, we can make sure we get questions answered. Okay, so just like before, we can still set up solution time. To show the current time step, we could put some kind of annotation here. If you ever want to shorten this up, show fewer significant digits, it's a C-style type formatting, so you can put a percent symbol and then put something like 0.4F to show float, 4 significant digits after the decimal point. You could also put E for exponential. It's a C language style formatting there. And once we close, it updates that. And now as we animate, obviously that's updating. One of the other ones, I'll just hit redraw to re-render. Another one that comes up quite a bit is primary slice position. And again, we could shorten up the formatting there. So now if we were to go in here and move this slice around, it would actually change the value here. So you can see dynamic text isn't just about labeling the time. It can be labeling other things as well. And again, clicking on the Help button in the text dialog will show you the full list of those dynamic text strings. Okay, so we've shown a lot of the analysis, and we showed some calculation in terms of the particle paths, but we can also do integrations within TechPlot, and both Scott and Darrell were talking about that in earlier sessions. So what we could do is just do a simple scalar integration in the Analyze menu. So this wouldn't be available in Focus, but it's available in 360. So we'll go ahead and go to Analyze and Perform Integration. And just to do something quick, even though this might not be too physically relevant, is we could just select row as a scalar variable. And for a long time, you've been able to integrate over zones, but just recently it was added so you can integrate over time strands. So back to our original discussion about the different segments of this cylinder, we can now integrate over that entire grouping over time. And we'll just select the interior zones. There's a set of zones here, and there's a set of zones further out. But I just want to concentrate on these inner zones, or the ones closest to the cylinder. So I'll go ahead and select those. And by the way, I just clicked and dragged down the list. That can be done across TechPlot. It can be easier than needing to hold down a Shift or Control key. Just click and drag down. Let's see. I think I wanted from 3 to 10 there. So you can always edit it here after the fact in the time strand window. And please don't feel discouraged on asking questions, even though I'm waiting till the end. Feel free to keep posting them here, and we'll revisit. Okay, and in this case, we could constrain the integration to closer to the cylinder itself. These are ordered data sets, so we have the ability to constrain based on the I, J, and K index ranges. So we'll choose I or J index from 1 to 2, which will keep it very close to the cylinder. This is the J is the radial dimension in this case. And we'll go ahead and choose to plot the results as, and we'll have a new result frame pop up. We'll also show the tabulated results. And when we're happy with all of that, we can go ahead and click Integrate. So we get our table, if we choose, and then we get the integration for each time strand. That's why you see the different lines here. So it's an integration of the result, which was our row, over time. So we could also sum these to get a full summation of regardless of what time strand it was. What's the fully summed integration of our scalar quantity over time? And we could do that by clicking on the XY line frame, choosing Compare XY Maps, choosing the sum, and then click on Solve Data. And now we can go back into mapping style and just hide everything except for the summation. And then we can click Control F for fit to full size to just fit the plot again. So you can see that we do have a relationship here over time, but if we take a closer look, so I clicked on plot and axis here. I just want to move this a little bit, the left position, so we can see these numbers. You can see there's almost no variation over time. If we go back to the animation, I'll go back to the beginning. You can see that doesn't surprise us too much. The quantity is not really changing much over time. So maybe not the best the best real-life vision of that, but just an example of how that works. It'd be, if you had a pressure over time that was going to be obviously changing a pressure buildup along one side of a stationary object, for example, this would definitely show you that. And also you can see the marker shows up here again to show where you are, where on this line you are in the solution time. Okay, so we've shown time animation, shows stream trace animation. Another type of animation is the keyframe animation, which is essentially an animation of a change in position or change in how the plot is oriented. So we'll just click on keyframe animation. And basically what you can do is just start appending these major view changes. So we could go in here and we could rotate and append that view. We could move the plot. I just clicked on the right mouse button and drag. We don't need to append that. And then I'll click on the middle mouse button. We could zoom in, and we could append. So once you've appended different views, and this may not be the most artistically pretty keyframe animation you've ever seen, but that's okay. So when we click Animate, it's going to smooth out the transition between our key frames. And then it will go ahead and show us an animation of this. So this can be very handy in PowerPoint presentation or just showing your fellow scientist or engineer something cool. And if oftentimes there can be something you want to focus in on as you go, and this will let you dynamically make that change and not have to depend on one view being okay for the entire animation. So another thing you can do is click on Options, and we can do the time animation concurrently as well. You can see a checkbox there now. So now it's when you click Animate All, it's not only going to show this change in the orientation, it's also going to continue showing the time animation. You can see that's moving and the time is ticking away. And then it's still showing the time animation of our integrated quantity here. So in all the animations we've shown, there's an on-screen option and a to-file option. So if you're done looking at this in TechPlot, you're happy with what you got, you can always choose the to-file option, and then when you click Animate All, it's going to bring you to a dialog that gives you additional options for how you want to export it. So new in this version is an FLV Flash and an MPEG-4, along with Windows Media Video. 3 more modern formats. The Flash FLV and MPEG-4 in particular should be compatible across Windows, Mac, and Linux. And FLV is actually somewhat close to what would actually be on YouTube, so that can definitely be handy. So what we can do is, I'll just export it as a Windows Media Video, and I'll choose all frames, so we get both of these frames in that view. And we can just opt to make it the full size that is shown on the screen. And then we just get to save this. And so we'll go ahead and process it here. And along with actually rendering each frame, it's got to do the compression as well. So perhaps that might take a couple minutes. So in the meantime, I see we're actually slightly over time. So I do apologize for that, although that was the end of the demonstration. So we're at the Q&A section here. Since we kind of answered them as they came up, we pretty much filled the time, but I can definitely go back now, and we can answer some of these other questions that came up. Okay, so one of the questions that came up was from Gary. I'm going to unmute you, Gary, and if you have the setup to talk, go ahead and talk, and we can talk about your question. If not, then I'll try and answer it through here. So I've unmuted you, Gary. I'll give you a couple seconds. If you have a microphone handy, go ahead and speak up, and we can talk about this. Otherwise, I'll. Okay, I guess not. That's okay. Okay, so Hugh's talking about animating stream traces. Let's see, animating the development of stream traces from upstream. Right? Am I mixing up the questions here? No, I think that's right. So his follow-up was, no, my question is to animate the development of stream traces from upstream to downstream. This is useful for visualizing the flow development without being clouded by many streamlines for the entire flow field. Yeah, I'm not too sure what you're referring to here. If anyone, well, I'm thinking this might be something we can talk about offline. So I should have your contact information. I can get in contact with you regarding that. Okay. Let's move down the list. Okay, another question came up. Can you have a rotating 3D geometry if the CFD analysis is done using a rotating reference frame? So I guess my question on this would be whether or not that rotation was explicitly defined in the coordinates of the final result, or if it's just shown statically. So if it's shown, if the rotation is shown explicitly within the XYZ coordinates, then you could definitely have it show in TechPlot. TechPlot's going to animate whatever you have. as the XYZ coordinates. Otherwise, there might need to be some work done to set up that relationship with the orientation. It might be something that could be done under the data alter menu, where you can actually edit parameters along with the macro, where it could actually go through each zone and change the XYZ coordinates based on rotation parameters. That would definitely be one way you could do it. Okay, let me move on down the list. And if I miss anyone's question, one thing that might help is if you raise your hand. There should be an icon to raise your hand. I can go look for your question, make sure I don't miss it. Okay. So are you going to talk about 3D stream traces specifically? I'm wondering how I can generate appropriate rakes for the 3D cases. Good question. So we didn't go over that, but we can go over that really quick right now. And by the way, those who can't join us because we're over time, I did want to thank you very much for joining us today. And I did want to mention that later in the year we will be doing a TechPlot Chorus series that's likely going to be similar to this series. And so look for more on that through our blog, through our website as it comes available. And now I will get back to the question on 3D streamlines. Basically, the short answer is it works in the same way in terms of setting a rake. The only difficulty that comes up would be that it's a little difficult to define that rake in 3D space. So the strategy employed here is once you click on this add a single or rake of stream traces, you can click on this placement plane option down below and choose an orientation that's best for you. And what this does is take away the ambiguity of the 3D space and allows you to define the streamlines on that plane. And so you end up getting what you expect. You can still do it interactively with as much control as you could do in 2D space by using the placement plane. Okay, moving down the list, can the intersection of the cylinder and the cut plane be visualized? Okay. So Max, if you're there and you have microphone, it might be good to talk about this one a little bit. I'm going to try unmuting you. If you have access to a microphone, go ahead and talk now. No. No microphones. That's okay. So to show the intersection, essentially, would you be looking for a line of intersection between the cylinder and the slice? If you're there, go ahead and answer in the chat. Again, that might be something maybe I could reach out to you offline. We have your contact information, so I can do that. Some of these that require some Q&A on what you're looking for can be tough to answer in these webinars, but I definitely want to help you out on this. So I will contact you. I've made a note to do that. So there's another question. Can you integrate over a slice? Yes, you can. What you would need to do is you would need to extract the slice. So go to Data, Extract Slices or Current Slices that you already have present. And then when you go to do an integration, it would be an integration over zones. You would select that slice, and then you'd be able to integrate spatially over that zone. Okay, moving down the list. How do you know what segment each line represents? Frank, was this regarding the this plot here, the solution time plot? Let's see, the plot before the one on the screen. Okay, Frank, if you have I'm going to unmute you in case you have microphone. So go ahead
Steve,
and talk if you can, Frank. Yeah.
Can you hear me, Steve?
Yes, I can hear you well.
Oh, no, it was when you plotted the, you did an integration over the segments. It was when I said the one before, when you had the 3D plotter, you had an integration over all of the segments. Previous to that, you had a plot with 8 lines, different colored lines, and I wasn't sure how you would know which line represents which segment.
Oh. So it did identify them by their time strand.
Oh, did it?
So if we were to show them again, well, there's definitely some overlap. We could have turned on the line legend, and it would have been a little bit more instructive.
I see. Okay.
On which one matched up.
But you don't know which segment you have. I mean, how do you know which segment that represents in terms of the picture of your segments? You know, to the top left of the line picture, your line legend is obscuring it at the moment. What I'm saying is, how do you know which of these segments?
Sure. Yeah, and there's. I mean, definitely we were able to see it where we turn off and on the different zones, but you're right. I don't see offhand a good way of labeling those, as in coloring them differently. Yeah. Well, actually, yeah, we could definitely do that.
Oh, different colors.
We could go in and color.
Some colors as a line.
Yeah. Let's see. Edge would probably be the way to go on that. So you can see that the color that differently. So having a style set up for a specific solution and importing it, that you would maybe create once and then import it for subsequent solutions that were the same. Go in the frame, save frame style, and then load that frame style. Let you get at that styling very quickly without having to do it again.
Okay.
And so you could have the line color match up with the edge color from the original plot.
Yeah. Could I know I have the microphone, I'm hogging it, but could I ask you a question about particle tracking?
Sure.
You showed animated streak lines or the particle going along the streak lines in the webinar. I asked you about particle, animating the particle paths, and you said you could animate, yes, the top picture. I'm unclear in my own mind what the circles are representing in time and space. I mean, are they particles? That is that the true position of a particle at a particular time?
Yes.
So
yes.
what?
So if essentially if particles continue to be released at the point where
Mm-hmm.
the streak, I mean the rate start point,
yeah.
That's where they would travel in real time based on the transient flow.
But you can't follow an individual particle. I mean, I would like to be able to set I'd rather be able to set off 100 particles and watch them at each time step where they are as a cloud.
You can adjust how you release them over time.
Uh-huh.
So you could have them released infrequently enough to where it would be one particle per streamline.
Mm.
Would that help?
That could,
or is
yeah,
it really?
Yeah.
And so it's not. Since it is using these streamlines as a starting point.
Only as a starting point. Yeah.
It's not essentially saying, okay, tell me what your particles are and we'll move them forward. It's using the streamlines to essentially do that. So you could still seed at your point, at the particles you want to look at.
Mm-hmm.
It would just need to be done through the streamline definition first.
But can I stop the animation at each delta t so I can see, where the cloud is at each time step? That's what I need to know.
You can definitely step through. I guess at this case, I'm just stepping through over time.
Mm.
But you mean step through in this?
In time, no. I mean, I want to set off a small cloud of particles and watch where they go. But I need to be able to see at each time step where the cloud is and how it has dispersed. So, I mean, the animation you're showing, it's unclear, which, I mean, I can't tell from those particles, where each part, to which group each particle belongs, let's say, because they're being set off all the time, I suppose. So if
it's showing over time the current position here.
Yeah. Mm-hmm. But it's hard to track, where the first set of particles, or let's make it more complicated, where the fifth set of particles are now. That is, you've set off particles, maybe 10 sets of particles now, say in this picture. So it's hard to know where where one set of particles is in the flow field. I mean,
okay, yeah, and then that would go back to probably don't release them as frequently because they're not marked in this case.
Exactly.
But yeah, they showed a different color based on which grouping they were in.
Yeah, I mean that was another question I had in terms of particle tracking. Because I've done something like this by changing the frequency of, well, I can't remember the right word, but if you switch on the scatter, and then you can change the point frequency. So I had 4,000 particles, and I put the time the frequency to 4,000. So I just saw the initial position and the final position. And that way, but they are the same color. That is, when you're pulling particles, when you're plotting a particle path, you can switch on scatter, so you can get the particles on each time step. And then you can change the frequency of the plotting of the particles, so you can kind of make it so that you can only plot the first position and the last position by setting the point frequency or the frequency of plotting of the points. But they are the same color then. That is, it would be nice if you could change the color of the particle based on the time history of the particle. If that makes sense. That's such that the initial position of the particle is a different color to the final position, so you can separate the initial to the final position of the particle. Because if they're moving randomly, you can't tell where it started and where it ends. In my case, maybe that's too detailed for this. I should get off.
Oh well, no, that's very good feedback. I can definitely provide product management.
Mm-hmm. Okay.
Because you're right, it is ambiguous which grouping is without. Coloring or without path, it's something showing what that particle's path was.
Yeah.
By turning on the mesh. The comments, and I'll make sure they get.
Yeah. Another comment on particle paths. It would be nice if you could just quickly erase the last particle path rather than all of them. As in the streak lines, you have a choice of deleting the last one or all. When you do the particle paths, you can only delete them all. If you look in the animated, when you do the analysis and you bring up the particle paths, the only choice you have is to erase all particle paths or not. I mean, I know you can go into the data and erase zones individually, but you know, when you bring up the streak line window, you have a choice, as I say, of deleting the last one, last streamline, or all of them. In the particle paths, you can only delete all of them. So it'd be nice to have another.
You can go in here.
Well, if you go in,
with the selector tool selected, you can actually click on a specific streamline and click press the delete key on your keyboard,
yeah,
and that will delete individually.
How about particle paths? Is that works the same?
For particle paths, you're right. It would be a matter of going into data, delete
zones, yeah.
And then deleting it, which can be a challenge because what does particle path number 5 mean? So it would maybe be a matter of having to show that selected one only to say, oh yeah, that is the one I want to delete, and then deleting it that way.
But as I say, in the when you go into streamlines, you can, because I'm doing this interactively, and I do a particle path. I see if I like it. If I don't, I would like to delete it. But I can't delete the last one. I have to either delete them all or do, as you just said, go out of that and go into the zones or data and calculate. So if you go into calculate particle paths and streamlines, see, it'll be at the bottom, delete all paths and streak lines. It would be nice if you had a choice to delete the last one.
Well, when they're calculated, they're all calculated together, and they replace the previous calculation. So
well, but I mean, you can calculate. The way I've been doing it, I calculate the streamline position. I then calculate the particle paths. I calculate paths individually, so that they have different zone numbers. But if you delete all particle paths, all of those zones disappear, as opposed to the last one you calculated. I mean, maybe it's not possible in the way that it's set up, but again, if you go to the same type of window for doing the streamlines, there is a choice: delete last one or delete all.
Yeah. Okay. So it's allowing you to do a similar thing in particle paths as you can in stream traces.
Well, I'm saying you don't have quite the flexibility in the particle paths, because in the streamlines you have there are two buttons. One is delete all, and the other is delete last.
Yeah.
So I'm just saying it'd be nice to have a delete last on this window as well.
Okay. Yeah, I can definitely get that back as well.
Okay.
Okay, so yeah, this has gone quite a bit longer than I had envisioned. It's actually really neat to see that a lot of people are still in here. Unfortunately, I cannot stay any longer. I have a meeting at 11:30 that I have to go to, but I will keep these Q&As, and we'll put something together to get these questions answered and get them to you. Yeah, it's great to see a lot of questions, but I want to be respectful of everyone's time that couldn't be here but still want some questions answered, and also make sure the people I'm meeting with next won't be without me. So again, thank you very much for joining me today, and thank you very much.